project I was working on for a little bit last year or so. I'm still kind of working on it, but it's been mostly done. We've mostly completed everything that we need to do. We're just working a little bit more on it. But actually, let me get into what we're doing. This project is kind of a joint project between like the English department at my college approached me and a couple of people in the CS department, and and basically what they wanted to do was try to figure out how to extract dialogue from a ton of contemporary novels at once, just because they wanted to do some research concerning dialogue and things like that. No, I think what they specifically wanted to do was look at how dialogue was being used in contemporary novels and things like that. So what they needed to do was like get all of the dialogue from like these I don't know, like 50, 100, 200 contemporary novels, which is way too much to like go through and like hand pick out dialogue. So that's kind of why they approached us. Um, and this is an interesting question, and I'm going to pose it to you guys. So why do you think this problem might require the use of an AI model instead of just like a simple thing that like maybe like searches the text for like quotation marks? And you can toss a couple of thoughts in the chat. They don't have to be right. They can just be whatever you're thinking about. Totally, yeah, because we're scraping through large amounts of data. But specifically, what I want you guys to maybe think about is, you know how usually like dialogues come between quotation marks? Why wouldn't we just use something that searches for like those quotation marks? Does anyone have any ideas? Toss them in the chat. I know this is a bit of a question to think about. Yes, exactly. You're completely correct. So some authors don't use quotes properly, and this is much more common in contemporary novels than it is in like older novels. And so that's the biggest part, that like it's hard to identify where dialogue is, especially in like modern and like postmodern novels where authors are like messing around with form and like things like that. Definitely, definitely. And then the other thing is that like some instances of quotes in books may not be like within dialogue. They might be used to like emphasize a word or like I don't know, things like that. Or like dialogue might be in italics maybe. So it's hard to tell. So I have a question for you guys. Let's look at this passage on the screen. And you can take a second to read it. I want you guys to see if you can identify the dialogue. And once you're done reading, toss in the chat maybe what you think the dialogue here is. Yeah, yeah, hi Papa, definitely am right here, I know. So what we can see here is we have hi Papa, and then we have these two lines. And it was easy for us to identify, especially hi Papa. So we could easily identify hi Papa using the word said, because said is a dialogue word. But then these two words are kind of formatted similarly to a paragraph. And we were able to recognize that because we like can actually like read the text and know what's going on. And like we understand that these are words people would say and that they're different from like the general like description here and here. So that's kind of an instance of us having to read and like analyze the text in order to find the dialogue. And if we were just searching for like maybe the word said or like maybe like quotes, we wouldn't be able to find all of the dialogue here. So we need to use a machine learning model. So here is something slightly different, and we're not going to find many contemporary novels like this. It's from Finnegan's Wake, if you've heard of it. It's very unique in that the language isn't English, but is also not like a distinct other language. Um, so it's kind of interesting. Um, I want you guys to take a moment to read this and see if you can toss in a chat where maybe a line of dialogue is. This is kind of a lot more difficult. Yeah, mm. Okay, yes, Aparna, this is an actual book, Finnegan's Wake by James Joyce. So this was a little bit of like, mm, this was kind of a little bit of a trick. I think I'm actually forgetting where the dialogue is, but it's a good portion of this. I think the dialogue like might start like around here, like maybe from like till you meet, and then it goes like until down here. So there's a fair bit of dialogue here. Um mm, it's mostly one huge monologue that like starts somewhere around here. Um I think around, yeah, around here the monologue starts and the monologue keeps going. Yeah, it is kind of a monologue, but the monologue like starts somewhere here. Like earlier than that, it's like internal thoughts and things like that. So this was very difficult, and it was like difficult for us to analyze and like see where the dialogue is. So an interesting thing that also came out of what we were looking at is to see if we could feed in maybe like this novel, which is like it like makes little sense, and see if like our model could maybe use the tricks it learned to like identify dialogue in here. But that was like an interesting little question that we thought about later. But first, let's actually get into what we were doing. So we were using okay, so in NLP, we haven't really talked about these types of models, but what they are kind of is that mm, they're kind of deep learning architectures that we can use to basically like deal with like various like NLP tasks, like reading sentences and things like that. And some of them are called transformers, some of them are called like other things. So what we're using is this model called XLNet. And XLNet is unique because it's a combination of a couple of different types of architectures. So previously, all we had earlier was this thing called BERT, which was like the main model that people used to use, and it's essentially stands for bi-directional encoder representation from transformers. Mm, so mm, kind of what it does is mm, it like it basically like if you look down here, it basically like ends up like masking certain words and seeing if it can like mm, predict what word would go there and sort of understand. So, like for example, here, input in our input, like a couple words would be masked, like dog and like lights, and then it would see if it could sort of like understand the sentence in order to like give back dog and lights. And that's kind of what BERT is doing. It like trains based on like masking certain things and figuring that stuff out. Transformers, on the other hand, are like a very interesting specific architecture, and you can see like a brief example of transformers in in maybe like the right hand side of this. So what it's doing here is it's reading the sentence, the animal didn't cross the street because it was too wide. And then it's seeing like which things are associated to what. So for example, it here is like just like a random word, but like it can be referred to like whatever. And how do we like tell which thing it is referring to. Because like it is actually kind of an important word sometimes since it refers to other things. But in the past, when we've looked at NLP, we've like um, mm, no, we've like maybe removed it as a stop word, but sometimes it's kind of important. So we can see what this is doing. It like looks at various things it could represent, and then the darkest portion here is street. So it would label it as street essentially. Um, this goes into more detail of a transformer. I'm going to skip going into this detail, maybe in the interest of time. But this is kind of a detailed version of the architecture of a transformer. If you're curious, you can reach out to me later. Um, so what XLNet does that's kind of unique is that it like mm, mm, what it does is, in addition to looking at the sentence as is back to front, it also messes around with like how the sentence is structured, just so it can kind of understand maybe what what the order the words are in, and two, what like the missing masked words are. And as you remember, it trains by like masking certain words and then trying to infer based on like what it knows what those words are and like retrieve them. So what it's doing is it considers like everything kind of around this word, and then it considers like a bunch of permutations of the sentences as a whole, and like looks through it in like very many different ways. Cool. This is a brief description of XLNet versus other models. And XLNet is basically interesting because, mm, um, so what it's doing is it's a it's taking BERT, and like, okay, let me explain this better using like this whole New York is a city. So what BERT was doing, and BERT was like the previous model that XLNet was improving on, is so let's say we have a sentence like New York is a city or something like on this. So what BERT does is it gets it like kind of gets confused. So it mm, they both they both know that like mm, that like New and like York both relate to city. But because like Bert is kind of like treating this more separately, it doesn't like really understand the relationship between New York, and it doesn't treat like New York together. So it'll like be like, oh, New is related to city, York is also related to city. So there must be like a little bit of association between New York. XLNet like skips that and is able to kind of understand like New York as a whole word, if that makes sense. And that's just a difference in the architecture and what it's doing with like masking certain words. It's dealing with like masking in a different way than BERT. And that's kind of like the biggest difference between BERT and XLNet. And it was interesting when XLNet like first was developed, it did like it did like a ton better. I don't remember the exact numbers, but it was like very significantly better. And now like as we get into like 2022, since this is like a very recent topic, more models that like even improve on XLNet are being developed and being published, and those are pretty cool. And I haven't gotten a chance to look into them in detail, because we have been using XLNet, but we're going to see if we can like eventually work on these other models. And briefly, what our method was doing is we kind of modified XLNet so that we could predict, mm, so that we could end up predicting. Mm, So, so what we were doing is XLNet has a bunch of different types. We were taking like the type of XLNet that was designed to predict the next word and to see basically what it would predict based on like the word before dialogue and like the word after dialogue, and essentially see if like dialogue was structured differently, or if like a word before, or if like a couple of words led up to dialogue or like finished a dialogue, and just kind of modified that using like whole chunks of text instead of like specific words. So we would maybe mask certain parts of the dialogue and see what it would do there to see if it could like understand maybe structured dialogue. And it actually did pretty well. I know I have Finnegan's Wake back up here. Um, so what Finnegan's Wake would be is like, since Finnegan's Wake isn't identical to any contemporary literature, mm, um, we would have to treat it differently, and it's just something we use to like analyze what our machine is doing. And I think our machine ended up like mm, our machine ended up like highlighting this whole paragraph as dialogue, didn't really understand the dialogue in this paragraph, but again, we weren't expecting it to work on Finnegan's Wake since it's not like designed for Finnegan's Wake. But it was pretty effective on most texts. Although we did have a couple of outliers. I think Heart of Darkness starts with just like a super long, like, I don't know, chapter long or like multi-page monologue that it got confused on. So we had to like take those texts separately, but it was pretty effective, which is fairly cool. Do we have time for this quick question? So I want you guys to toss in the chat maybe how you would expand on this project, or like maybe besides the field of like, I don't know, literature research, what are other potential applications for something like this? And you can toss some ideas in the chat.